What's going on, everyone? In today's video, we're going to be taking a look at quadratic models and our first little property about quadratic models, which is going to be the axis of symmetry and the y-intercept. Let's take a look. So quadratic modeling is going to model quadratic equations, and it's actually quite useful. You can do it from something that might seem a little obscure, like taking the shape of a banana, all the way to modeling roller coasters and motion and g-forces and just kind of the overall track layout. You could also use it for, if an airplane is dropping packages, what kind of path are those packages taking, all the way to dolphins jumping up and what kind of motion they're taking as well. So as per usual with linear functions, we're going to have an input and an output. So you can see here I have function notation with my function right here. And x is going to represent, in this case, for the dolphins jump, circle the next one. In this case, it's going to be the horizontal distance that this dolphin's going to travel. That's going to be our x. And then f of x, which is going to be our y, our output, is going to be the vertical height. So in this case, we have horizontal distance, and then we have vertical distance or vertical height. So that is one way that quadratic models are used. But before we get into that, let's take a look at some of the basic properties that can help us break these down. So here we just have a couple definitions. We have the vertex of the parabola, meaning the minimum or maximum point on the graph. In this case, it's going to be right here. I do not go lower than that point right there. So that is going to be my minimum, and it's going to be my vertex. So right there is my vertex, and that's going to be at 0, 0 in this case right there. Again, just the minimum or maximum. The axis of symmetry of a parabola is a line of symmetry which passes through the vertex. What that is it's going to be a straight up and down line that divides the parabola in half. It's always going to go up and down with quadratics, and it's going to be an axis of symmetry. It's going to be where you reflect about. It's going to split it in half. And so the general quadratic function that we have is this guy right here. F of x equals ax squared plus bx plus c. So these x's are going to be our inputs, our variables. That's why it's right here in our function notation. And then a, b, and c are going to be what's called constants. So a is just a coefficient in front of x squared, b is just a coefficient in front of x, and then c is the constant. It's also going to be our y-intercept. So let's take a look at some problems and see how we can use the axis of symmetry as well as the vertex to sketch and solve a couple problems. So I'm tasked with plotting the graph of negative 0.5x squared plus 7.5x minus 18. Sketched on paper, we want to show the general shape accurately, label the coordinates of any axes intercepts, as well as label the coordinates of any vertices. So there's a little formula to help us out with the axis of symmetry. So we can abbreviate that as AOS, as axis of symmetry, and that's going to be equal to negative b over 2a. You'll also see it written as x is negative b over 2a because, again, it's a vertical up and down line, which takes the form of x equals something, some kind of constant. So why even use the axis of symmetry? Well, if you think about it, it's symmetrical, right? So we are dividing a graph in half. And where is that going to be seen? Well, just like how we saw up here with our vertex, we see that it's kind of bottoming out right here. And that's also where the axis of symmetry passes through. What that means is that whatever the axis of symmetry is, that x equals blah, 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 that is going to be the x-coordinate of our vertex. So not only do we know where the graph is going to meet, we can figure out the x and y coordinates of the vertex to further help our sketching. So what does that look like when we're actually doing a problem? So x equals negative b over 2a. So I quite literally plug in values, because remember that with my general quadratic form, something like that. So I would take my negative sign. What is my value of b in this equation? What is my value of b in this equation? It's 7.5 all over 2 times a. What's my a? It's negative 0.5. So what would my x value end up being? It would end up being 7.5 positive. Put that in your calculator, do it in your head, whatever you got to do. So x is equal to 7.5. So let's go ahead and let's hold on to that. Now that I know what the value is for my axis of symmetry, I now know the x-coordinate of my vertex. So if I actually plug in this value right here into my function, I'll get out the y-coordinate, my output of the vertex. So if I plug in 7.5 into f of x, you will find that the value that comes back out is 10.125. So that means that my vertex is going to be at 7.5, 10.125, just like that. So we now know what the vertex is, and that's going to help us a lot. What we can also do is figure out what the axes intercepts are. So let's think about this. Easy one right off the bat is the y-intercept, because if I plug in 0 into x, if my x-coordinate is 0, that means whatever my output is has to be my y-intercept, and you'll find that that is negative 18. So I'm going to have a point for sure at 0, negative 18, and it's going to follow that. So how can we figure out what our x-intercepts are now that we know that our y-intercept? Well, again, just like how our y-intercept has an x-coordinate of 0, my x-intercepts are going to have a y-coordinate of 0. So what you can do is plug in 0 for your output, and you can make that equal to the equation. So there's a couple ways to do this. You can use the quadratic formula. You can put this into your graphing calculator. Maybe you have permission from your teacher or your curriculum to use nsolve or quadratic solve or whatever it happens to be. There's multiple ways to go about this, but either way, what you're going to end up with is 3 and 12 for values that make this equation equal to 0. So that means that not only do I have my y-intercept at 0, negative 18, it means I have x-intercepts at 0, oops, sorry. That means I have x-intercepts at 3, 0, as well as 12, 0. All right, let me clean up a little bit. All right, so now that I know that, let's kind of plot this out a little bit. I know that I have an x-intercept at 3, 0. I have an x-intercept at 12, 0. And I'm going to have and my vertex is going to be at 7.5, 10.125. So let's go ahead and let's call this right here 7.5. And let's call this up here 10.125. Again, it's just a sketch. It does not have to be perfect. It's going to go there, and it'll cross the x-axis here and cross the y-axis down there, as well as come here and then keep going down as well. Now, it's not a perfect drawing. If you put it into Desmos, it's going to look much, much cleaner. But again, this is just a sketch. We want to go over the intercepts, which we got here, here, and here. We want to go over the vertex, which was 7.5, 10.125. We want to make sure that it is fulfilling all the requirements of the question that we are asked. So the last part is, what is the domain and range of this function? Well, you can already kind of tell just by either looking at the equation here or by looking at the graph with these arrows. There's nothing stopping me from putting in a value in for x. There's no divide by 0 error. There's no root of a negative number error. So my domain is going to be all real numbers. And if you want to write that in inequality notation, you can go ahead and write it like that. And hopefully you have a better infinity sign than I do. Now, what about the range? Well, that's a little bit different. The range, it's way easier to look at the graph here. And I can already see that, okay, I'm going downwards here. And I'm going downwards here. But I am peaking right here. This is my maximum value of the vertex. So in terms of y, what is the furthest upwards I go on the y-axis? Well, it's right here, which I know is my y-coordinate of the vertex, which is 10.125. So I know that my y value has to be less than 10.125. And there it is. Or equal to, sorry, y has to be greater than or equal to 10.125. So there's the domain and the range of the function. Again, there's other ways to write it. It depends if your teacher wants you to write in set builder notation, inequality notation, interval notation. There's multiple ways, but the overall idea is that for x, it's from negative infinity to infinity. There's no restrictions. And for range, as long as y is below or equal to 10.125, you're okay. Equation of the axis symmetry for the graph we just did. So we already did that using negative b over 2a. But there's one other method of solving it, which maybe you might find easier depending on the context of the problem you're given. What you can actually do is just take the averages of your x-intercepts. So if you take the x-coordinates of the x-intercepts, average them out, you'll actually find out what the axis of symmetry is. And that should actually make a lot of sense with what we're given here. Because if you think about this is kind of the left bound, and this is kind of like your right bound, well, then the axis of symmetry has to be in between those. So if we want to use this method, it's actually not that bad, because I know that one of them was 3 and the other one was 12. Well, okay, I have 3 plus 12 all over 2. I'm going to have 15 over 2, and I'm going to have 7.5. So my axis of symmetry is going to be the line x equals 7.5. So again, in the problem before, we weren't given those x-intercepts. We had to find them. So maybe you want to find those x-intercepts and find the axis of symmetry that way. Maybe you want to use negative b over 2a. It all depends on the context of the problem and whichever one you're more comfortable with using. All right. So again, I hope that helps shed a little bit of light of how you can sketch a graph, how you can find the intercepts, both y and x, find domain and range, as well as use the axis of symmetry using two different approaches, the negative b over 2a, as well as the average of your x-intercepts. Hope that helps, and I'll see you all in the next video.